Assalamu alaikum. Welcome to Virtual University of Pakistan. My name is Sara Ahmed, the lecturer on the course Sta408 Design and Analysis of Experiment is going to deliver on the behalf of Virtual University of Pakistan. It's your lesson number 7. Efficiency of Latin square design. About Latin square design, you have studied in the previous lectures. Now we will move towards, or we will discuss about the efficiency of Latin square design relative to randomized complete block design, abbreviated as RCBD, in which we will study the two cases. The formula for the case 1 is, as you know that in a Latin square design, there is a row and column. Both are restricted. But in randomized complete block design, there is one-way blocking only. So when taking rows as blocks, you have to use the formula 1 over k sc square over se square plus k minus 1. And when we will take column as blocks, we will use the formula 1 over k sr square over sc square plus k minus 1. In this 1 over k your number of rows or number of treatments or number of columns, because in a Latin square design, k treatments and k cross k design. So you can say it's a number of rows because we are taking rows as blocks. It's your mean square for columns, and this is your mean square error, and again k number of rows minus 1. It's a relative efficiency of Latin square design to randomized complete block design, taking rows as blocks. It's a relative efficiency of Latin square design to RCBD when taking columns as blocks. Here SR square is mean square rows, and this is mean square error. And again k is the number of rows, number of columns, or number of treatments. When you will use the rows as blocks, in the formula you will put mean square for columns. And point to be noted, when you will take the columns as blocks, use the mean square rows in the formula. Efficiency of Latin square design relative to CR design. The formula is relative efficiency of Latin square design to CR design is 1 over k sr square plus sc square. Sr square again means square rows, sc square means square columns, se square is the mean square error. This is also a mean square error. Now we will consider an example for the understanding of the efficiency of Latin square design. So by solving this example, you can understand that how we can calculate the relative efficiency of this design. Example is, consider an experiment to investigate the effect of 4 different diets on milk production of cows. There are 4 cows in the study. During each lactation period, the cows receive a different diet. There are 4 diets A, B, C and D. There are 4 cows, 1, 2, 3, 4, and 4 lactation periods, 1, 2, 3, 4. Assume that there is a washout period between diets so that previous diet does not affect future results. Lactation period and cows are used as blocking variables. Here, lactation period in a rows and the cows in the columns both are used as blocking variables. A 4x4 latent square design is implemented. You can see the design here. The mean square period, mean square cows and mean square error are 49.06, 18.2292 and 0.8125 respectively. Estimate the relative efficiency of latent square design to randomized complete block design. First, by taking the cows as blocks. Secondly, by taking lactation periods as blocks. In the first part, cows are in the columns. So it means taking the columns as blocks and periods are defined in the rows. So the meaning of second is by taking the rows as blocks. In this example, the mean square period is 49.06, mean square cows is 18.2292 and mean square error is 0.8125. The first part is by taking the columns as blocks. Relative efficiency of latent square design to RCBD by taking columns as blocks. The formula is 1 over K S R square over S E square plus K minus 1. Put the values 1 over 4. SR square is 49.06 over 0.8125 plus 4 minus 1. It's 1 over 4. 49.06 over 0.8125 plus 3. The answer is 15.8454, or you can say 15.85. It means a randomized complete block design with just cows as blocks would cost about 16 items, as much as the present latent square design to achieve the same sensitivity. Now we will solve the second part. By taking rows as blocks. Relative efficiency of latent square design to RCBD when taking rows as blocks. The formula is 1 over K SC square over SE square plus K minus 1. By putting the values, we get 1 over 4. SC square is 18.2292. SE square is 0.8125 plus 3. The answer is 6.36. Another example is, consider the given ANOVA table for 5 brands of air cleaner in a 5x5 latent square and find the efficiency of this design relative to CR design. CR design means completely randomized design. The ANOVA table is given in which the source of variations, degrees of freedom, sum of squares, mean square and F values are provided. By using the mean square, rows, columns and error, we can find the relative efficiency of latent square design to completely randomized design. Relative efficiency of latent square design to CR design, the formula is SR square, mean square for rows, plus SC square mean square for columns plus K minus 1 mean square error divided by K plus 1 and mean square error. It's E. Put the values in the formula. SR square is 1128.14 plus 544.44 plus 5 minus 1. SE square is 2887.29 and its divisor is 5 plus 1, 2887.29. By solving this, you will get the answer 1.34. It means 134%. It is greater than 1. That is approximately 34% more observations per treatment would be required in a completely randomized design to obtain the same precision for estimating the treatment means as with this latent square design. Multiple comparison tests. If F test after the analysis of variance rejects our null hypothesis. As you know that when we perform the analysis of variance, we finally calculate the F test value and compare it with the tabulated value. That F value, if after the analysis of variance rejects our null hypothesis, all we can conclude is that the K population means are not all equal. जैसे हम H0 में बनाते हैं कि all the K population means or treatment means or column means or row means are equal. And H1 में हम define करते हैं कि not all the population means are equal. तो जब आपका null hypothesis reject हो जाए तो conclusion क्या आता है कि जो K population means है वो equal नहीं है. This type of conclusion might not be sufficient to satisfy the experimenter. Rather, he would like to know which means or set of means might differ significantly from each other. For this purpose, several tests based on different viewpoints have been developed to make comparison between pair of means. जब हम ट्रीटमेंट मीन्स के लिए हाइपोथेसिस फॉर्मुलेट करते हैं और वो रिजेक्ट हो जाए फिर आप उसमें कंपैरिजन करेंगे डिफरेंट पेयर ऑफ मीन्स बना के. Such tests used as a follow-up to F test are called multiple comparison tests. Most commonly used tests are Fisher's least significant difference और LSD test. हम इस लेक्चर में जो आपका नंबर 1 टेस्ट है LSD टेस्ट इसको स्टडी करेंगे. Others are for just information. The student Newman-Kuhl's multiple range test, the Dunkel's multiple range test, the Sheffield's test, and the Tukey's T method. Least significance difference test or LSD test. When the null hypothesis of equal means is rejected by F test after ANOVA, यही बात है जो अभी मैंने आपको previously बताई है. We can test the significance of differences between means of K samples or treatments by computing the smallest difference that would be judged significant and to compare the absolute values of all differences of means with it. This smallest difference is called the least significant difference or LSD, and it is given by LSD is equal to T alpha by 2 nu 2 mean square error over R or इसका square root. Two means are declared to come from populations with significantly different means when the absolute value of their difference exceeds the LSD. इसका मतलब ये है कि जब आपका नल हाइपोथेसिस रिजेक्ट हो जाए तो आप अपने ट्रीटमेंट मीन्स के पेयर्स बना लें. उन पेयर्स की एब्सोल्यूट वैल्यूज को आपने कंपेयर करना है जो आपकी वैल्यू आएगी LSD से। एंड इफ द एब्सोल्यूट वैल्यू ऑफ देयर डिफरेंसेस एक्सीड्स द LSD, तो आप डिक्लेयर करेंगे कि वो पेयर ऑफ मीन्स, वो जो दो मीन्स हैं, टू कम फ्रॉम पॉपुलेशंस विद सिग्निफिकेंटली डिफरेंट मीन्स। इसको मजीद अंडरस्टैंड करने के लिए हम एक एग्जाम्पल सॉल्व करेंगे। 5 fertilizers A, B, C, D and E were tested by arranging plants in a Latin square design in a field. The rows and the columns in the table are rows and columns in the field, and yields in bushels per plot are shown. Columns हैं 5, rows हैं 5, treatments हैं 5. The Latin square design is shown in the table. This is your Latin square design. Analyze the data for evidence at 5% level. Alpha ले लेंगे आप 0.05. That the mean yields are not equal for the 5 fertilizers. Also pick up the best fertilizer. अब इस एग्जाम्पल में उसने आपको कहा है कि आप इसको सिर्फ टेस्ट करें कि मीन यील्ड्स इक्वल नहीं है फॉर 5 फर्टिलाइजर्स, यानी आप एक ही हाइपोथेसिस बनाएं, आइदर इट्स अ लेटिन स्क्वायर डिजाइन। अब आप इसमें हाइपोथेसिस एक ही चेक करेंगे कि जो आपके ट्रीटमेंट मीन्स हैं फॉर 5 फर्टिलाइजर्स वो इक्वल नहीं है। इसको आप H1 में रखेंगे, H0 में आपका होगा कि मीन यील्ड्स इक्वल हैं। लास्ट में उसने कहा है कि ऑल्सो पिकअप द बेस्ट फर्टिलाइजर। ये बेस्ट फर्टिलाइजर हम LSD टेस्ट अप्लाई करके चेक करेंगे इफ हमारा एनालिसिस ऑफ वेरिएंस रिजेक्ट कर दे हमारे नल हाइपोथेसिस को। फर्स्ट स्टेप हाइपोथेसिस, second level of significance which is given in example alpha 0.05, test statistic। hypothesis क्या होगा, H0, the mean yields for all the 5 fertilizers are equal. Alternatively, not all mean yields for the 5 fertilizers are equal. Test statistic F, mean square for fertilizers, because आपने एग्जाम्पल में सिर्फ इसी को टेस्ट करना है क्योंकि आपसे सिर्फ इसी को एनालाइज करने के लिए कहा गया। मीन स्क्वायर फॉर एरर इसके डिवाइजर में है, इट इज इक्वल टू ST स्क्वायर ओवर SE स्क्वायर। दिस इज योर लेटिन स्क्वायर डिजाइन। यूजुअल मैनर में जिस तरह हम प्रीवियस लेक्चर्स में लेटिन स्क्वायर डिजाइन को सॉल्व करते आए हैं, बिल्कुल उसी तरह से आपने एनालिसिस परफॉर्म करना है। यहाँ पे आप अपना रो टोटल निकाल लें और इसका स्क्वायर, CJ कॉलम टोटल एंड स्क्वायर 36.4। मैं इसकी बहुत ज्यादा डिटेल में नहीं जाऊंगी क्योंकि ये आप प्रीवियस लेक्चर्स में इन डिटेल स्टडी कर चुके हैं। And it's your grand total 196.5, 35.9, 30, 40.1, 39.6, 50.9, and its sum is also 196.5. The square of 36.4 is 1324.96, 1576.09, 1681.00, 2034.01, 1176.49, and the total is 7792.55. The square 1288.81, 900, 1608.10, 1568.16, 2590.81, and finally its sum is 7955.79. इन वैल्यूज को यूज करते हुए आप सम ऑफ स्क्वायर्स फाइंड आउट कर सकते हैं। यहाँ पे आप एक और बना लें, IJYIJH स्क्वायर, ईच ऑब्जर्वेशन का स्क्वायर। ये आपके पास इसका फाइनली सम आ जाएगा 1829.83। ये मैंने टोटल आपके पास लिख दिया है, आप ईच ऑब्जर्वेशन को स्क्वायर करके उसका सम कर लें। अब लेटेंट स्क्वायर डिजाइन में से हर फर्टिलाइजर की वैल्यूज को सेपरेट कर लिया। इसका टोटल आपके पास आएगा 34.2, 32.3, 65.6, 39.8, 24.6। इसके मीन भी फाइंड आउट कर लें क्योंकि हमें पेयर ऑफ मीन्स को चेक करना होगा। 6.84, 6.46, 13.12, 7.96 and finally 4.92। देन लेटेंट स्क्वायर डिजाइन के फॉर्मूलाज अप्लाई करें और आपके पास टोटल एसएस आ जाएगा बाय यूजिंग द फॉर्मूला yij h square minus correction factor. Correction factor is equals to grand total square over k square. Row sum of squares find out कर लें। ri square over k minus correction factor. Column sum of squares summation j cj square over k minus correction factor. Treatment or fertilizers sum of squares is summation h th square over k minus correction factor. Finally, error sum of square tss minus rss minus css minus treatment sum of squares. Now put the values in the ANOVA table. Rows, columns, treatments or fertilizers, error and total. इसकी डिग्रीज ऑफ फ्रीडम 4, 4, 4, 12, 24। ये कैसे आई हैं ये हमने प्रीवियस लेक्चर्स में देखा है, इसलिए आप उसी तरह से लेटेंट स्क्वायर डिजाइन को सॉल्व करेंगे जैसे हम उन लेक्चर्स में करते रहे हैं। 46.67। इस लेक्चर में हमारा बेसिक पर्पस है कि हम LSD टेस्ट की एप्लीकेशन को स्टडी करें। सो मैं उसकी डिटेल के लिए आपको ये एग्जांपल सॉल्व करवा रही हूँ। इसकी रिक्वायरमेंट है कि आप लेटेंट स्क्वायर डिजाइन को पहले सॉल्व करें। LSD टेस्ट सिर्फ लेटेंट स्क्वायर पे अप्लाई नहीं होता, बल्कि ये कंप्लीटली रैंडमाइज्ड डिजाइन की एग्जांपल हो या रैंडमाइज्ड कंप्लीट ब्लॉक डिजाइन की एग्जांपल हो। जब भी आपके पास रिजेक्ट हो जाएगा नल हाइपोथेसिस, तो फिर आप ट्रीटमेंट मीन्स को LSD टेस्ट अप्लाई करके चेक करेंगे। अब हमें सिर्फ F चाहिए फर्टिलाइजर्स के लिए। 49.15 over 2.34. Answer is 21. And the fifth step is your critical region. Reject H naught if F is greater than or equal to F 0.05412. F के टेबल में जब आप ये वैल्यू देखेंगे 412 के साथ 0.05 में, तो ये आपके पास आती है 3.26 and your calculated F is 21. 21 is greater than 3.26, so it means we will reject the H naught, our null hypothesis. The conclusion is, since the computed value of F21 falls in the critical region. We therefore reject our null hypothesis. Hence, we conclude that the data provides sufficient evidence to indicate at the 5% significance level that the mean yields for 5 fertilizers are not equal. इस एग्जाम्पल में आपसे यही कहा गया था कि आप एनालाइज करें फॉर द एविडेंस कि 5% लेवल पे मीन यील्ड्स इक्वल नहीं है फॉर द 5 fertilizers. So our analysis also shows that the mean yields for the fertilizers are not equal. Now the F-test rejects our null hypothesis, so we can apply the least significance difference test here. Now we compute the least significance difference to determine which fertilizer is to be considered the best one. आपके पास treatments हैं A, B, C, D and E और हमने इसके treatment means find out किए हैं. Y bar A is 6.84, Y bar B is 6.46, Y bar C is 13.12, Y bar D is 7.96, and finally Y bar E is 4.92. अब आप possible pairs बना लें. Y bar A minus Y bar B, Y bar A minus Y bar C, Y bar A minus Y bar D, Y bar A minus Y bar E. Y bar A minus Y bar E. Y bar B minus C, Y bar B minus Y bar D, and Y bar B minus Y bar E. Then Y bar C minus Y bar D, Y bar C minus Y bar E, finally Y bar D minus Y bar E. ये आपके पास 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 पेयर्स. ये चेक करने के लिए कि कितने पॉसिबल पेयर्स बन सकते हैं, आपके जो आपके ट्रीटमेंट्स हैं कॉम्बिनेशन 2 यूज करें. यहाँ पर 5 थे, 5C2, 10 पेयर्स हमारे बनेंगे. इसी तरह अगर 6 ट्रीटमेंट हो या 4 ट्रीटमेंट्स हो तो आप उसके अकॉर्डिंगली कैलकुलेट कर सकते हैं. और सीक्वेंस में मैंने ये पेयर्स बनाए हैं. अब आपको इन पेयर की वैल्यूज फाइंड आउट करनी है. इसमें पुट करें 6.84 माइनस 6.46, ये Y बार A है और ये Y बार B है. 6.84 minus Y bar C 13.12, 6.84 minus Y bar D 7.96, 6.84 minus E is 4.92, 6.46 minus 13.12, 6.46 minus Y bar D is 7.96, 6.46 minus ये साइड पे एब्सोल्यूट है 4.92, Y bar C is 13.12 minus 7.96, 13.12 minus 4.92, D 7.96 minus 4.92. अब ये एब्सोल्यूट डिफरेंसेस इनको कैलकुलेट कर लेते हैं. The first difference is 0.38, 6.28, 1.12, 1.92, 6.66, 1.5, 1.54, 5.16, 8.2, 3.04. जो भी इसमें वैल्यूज नेगेटिव आ रही हैं वो इस एब्सोल्यूट की वजह से पॉजिटिव हो जाएंगी. अब आपको इसको कंपेयर करना है विद LSD वैल्यू. LSD वैल्यू आप कैसे फाइंड आउट करेंगे? जो हमने फॉर्मूला देखा था उसमें वैल्यूज पुट करें. फॉर्मूला टू फाइंड आउट द LSD वैल्यू इज T alpha by 2 comma nu 2 mean square error over K. T alpha by 2 0.05 divided by 2 0.025 कॉमा यहाँ पे जो आप न्यू यूज करेंगे वो आप एरर की डिग्रीज ऑफ फ्रीडम का यूज करें. दैट इज 12. मीन स्क्वायर एरर है आपके पास 2.34 and 5 treatments. टेबल वैल्यू को T 0.025 12 T के टेबल में आपने 0.025 के लिए 12 डिग्रीज ऑफ फ्रीडम पे चेक करना है तो आपके पास आ जाएगा 2.18. You will get 2.18. And by solving this expression 0.96, finally 2.09. It's your LSD value. और जब हमने इसकी डिटेल डिस्कस की है स्टार्ट में, here it is defined two means are declared to come from populations with significantly different means when the absolute value of their differences exceeds the LSD value. अब हमने LSD value भी find out कर ली है और absolute differences भी find out कर लिए. अब हम इनको compare करेंगे. The LSD value is 2.09 for all, 2.09, 2.09. We will compare the pair values with the LSD value, which is 2.09. Now you can see that the first pair difference is less than. Decision is it is less than from LSD value. The decision is it is insignificant. It's greater than, significant. It is less than, it is also less than. Insignificant difference between the pair of means, it is also insignificant. This is greater than. It is less than, this is again less than. Both are providing insignificant results. And these three are greater than, showing significant results. From the significant results, you can see that the fertilizer C is the best one, as the mean yield for fertilizer C differs significantly from the mean yields of all other fertilizers. For further practice, another example is perform the analysis of variance on the following data and analyze the treatment means using the LSD test with a 0.05 level of significance. There are 6 treatments in this example and 4 blocks. You can see in the layout Treatments are showing by the numbers 1, 2, 3, 4, 5, 6 and blocks are also showing by the numbers 1, 2, 3, 4. You have to analyze for the treatment means. First step is hypothesis. You have to formulate a hypothesis just as H naught mu dot 1 is equal to mu dot 2 is equal to mu dot 3. It means that the mean of the first treatment is equal to the mean of the second one is equal to the mean of the third treatment up to so on mu dot 6. All the 6 treatment means are equal. It is formulated in the null hypothesis. Alternatively, H1 is showing that not all 6 treatment means are equal. Level of significance, it is defined in the example. Use 0.05. Test statistic. You have to analyze only for the treatment means. So F is equal to mean square for treatments over mean square for error. Fourth step is the calculation. You have to solve this question by yourself properly. I am just providing you a base that how you can proceed. Here you will find out the block total bi dot square, just like in the randomized complete block design. Here you will find out the treatment total square and the means as well. Also find out each observation square and then its sum. Find out all the sums and proceed it for finding out the sum of squares and mean squares and finally the F value. The values would be in the ANOVA table just as source of variation between treatments. Its degrees of freedom is 5 because there are 6 treatments. 6 minus 1 is 5. Source of variation between blocks. There are 4 blocks. Degrees of freedom would be 4 minus 1, 3. And error, its degrees of freedom 15. Total degrees of freedom is 23. सम ऑफ स्क्वायर्स की वैल्यू मैं आपको बता रही हूँ और जब आप इसको सॉल्व करेंगे तो इससे मैच कर सकते हैं कि आपका आंसर ठीक है या नहीं. 103.83. Mean square for treatments 10.37. For blocks 9.50 and mean square error is 1.57. You have to only find out the F test value for the treatments. So it is 10.37 divided by the mean square error, which is 1.57. Answer is 6.61. Fifth step is critical region. Reject H naught F. Your calculated value is greater or equal your tabulated value 0.05 515 because you are analyzing for treatment, so degrees of freedom for treatment हम यहाँ पे use करेंगे and this is the degrees of freedom for error. Your calculated F is 6.61 and your tabulated value 0.05 515 is 2.90. You can see here that the calculated value is greater than the tabulated value, so we will reject the null hypothesis. How you can write the conclusion? We reject the null hypothesis of equal treatment means as the computed value of F, which is 6.61, exceeds the table value. As the null hypothesis is rejected using F test, we therefore apply the LSD test to find out which means differ from each other. The least significant difference is given by LSD is equals to T alpha by 2 nu, 2 mean square over R square root. प्रीवियस एग्जाम्पल में मैंने यहाँ R की जगह पे K यूज किया था बिकॉज इन अ लेटेंट स्क्वायर डिजाइन नंबर ऑफ रोज, नंबर ऑफ कॉलम्स और नंबर ऑफ ट्रीटमेंट्स इक्वल होते हैं. बट इन दिस डिजाइन you will have to put the values for the rows. General formula is this. According to the layout, you can adjust it. If there is a latent square design, you can put it here or K. Now we will find out the LSD value. T 0.025. 0.05 को divide करेंगे 2 पे 0.025 and the degrees of freedom for error is 15. Value of the mean square is 1.57. Number of rows which are blocks that are 4. Final answer is 1.89. Your LSD value is 1.89. Now we will make up pairs. There are 6 treatments. You have to use 6C2 combination, 15 pairs. How you can make the 15 pairs? Y bar 1 minus Y bar 2, Y bar 1 minus Y bar 3, and use the absolute values of the differences. Y bar 1 minus Y bar 4, 1 minus 5, finally 1 minus 6. Now start from the second mean. Minus third, Y bar 2 minus Y bar 4, minus Y bar 6, Y bar 3 minus Y bar 4, Y bar 3 minus Y bar 5, Y bar 3 minus Y bar 6. Now start with the fourth mean. Minus fifth, Y bar 4 minus Y bar 6, and lastly Y bar 5 minus Y bar 6. Put the values here. The mean of the first treatment is 1.75 minus second one is 4. 1.75 minus third treatment mean की value है 4.75. 1.75 minus fourth treatment mean 5.75. 1.75 minus fifth treatment mean की value है 3.50, and sixth treatment mean is 1.75. The difference is equal to 2.25, 3, 4, 1.75 and 0. Further you have to calculate it. For some of the pairs, I am showing some results. The first difference between the first treatment mean and second treatment mean is greater than the LSD value. It means it's a significant difference. Second one is also greater than, third one is also greater than, both are significant. This one is the less than, so it is showing the insignificant difference. And this pair is also less than, it is also insignificant. Further, you will solve this example properly and compare the results, including another example, which is the effects of 4 types of graphite coaters on lightbox readings are to be studied, as these readings might differ from day to day. Observations are to be taken on each of the 4 types every day for 3 days. The results are as follows. The days in the rows are represented by the numbers 1, 2 and 3, and the graphite coated types are written in the column shown as M, A, K and L. Observations are noted. Construct an analysis of variance. Determine at 0.05 level whether there is significant difference between coated types. Apply the LSD test to locate significant difference between the various pairs of coated types. In this example, we have to determine whether there is significant difference between coated types. It is your H1 because H0 always shows there is no significant difference. You will write it as hypothesis. H0 will be there is no significant difference between coated types, and H1 is there is significant difference between coated types. Second step पे level of significance alpha 0.05 which is given in example. थर्ड स्टेप पे है टेस्ट स्टेटिस्टिक. आपको जो सम ऑफ स्क्वायर्स हैं वो रोज और कॉलम्स दोनों के लिए फाइंड आउट करने हैं, बट यू हैव टू एनालाइज ओनली फॉर द कोटर टाइप्स. देन योर एफ विल बी मीन स्क्वायर फॉर कोटर टाइप्स over mean square error. Fourth step is calculation. Source of variation between coater types, between days, error and total. Degrees of freedom, sum of squares, mean squares and f. Mean square की values हैं 0.51 for coater types, 0.10 for days and error is 0.09. It's 0. You have to solve this example, and we have discussed it previously. When the null hypothesis is rejected, then we go for the LSD test. LSD test की value है 0.60 by using the formula, and the means for the coater types will be y bar m 4.27, y bar a 4.87, y bar k 5.27 and y bar L will be 4.73. Compare the differences between the pair of means of coater types with LSD value, and finally write the decision which pair of means is significant and which is insignificant. Complete this example. Hope now you will understand that how we can estimate the efficiency of the latent square design and how we can apply the LSD test on the various designs. Thank you so much.